our job when it comes to new material, I would say it's very simple. We're going to finish what we started like probably more than a week ago, which is the shear design for beams and one-way slab, which I'm pretty sure that this will be like a piece of cake, will be easy. But I need few things to talk about before we hit this point. So I'm gonna start here with the assignment number 5. So assignment number 5, you guys submitted to me, I think before the weekend. I spent some time, actually I spent my weekend working on your midterm exam and on your assignment number 5. But here are few points that I noticed those are very, very common problem with the students. Actually, before I start, I would like to thank some individuals for their effort on the assignment. Some assignment, they were notably great. It's fantastic effort. You guys have seen some, I would say thank you on your assignment. Some of you really, really went beyond my expectation and generated a fantastic piece of work. Thank you so much. I really appreciate your effort. Okay, and again, same as I give the credit to those individuals, there are some of you guys are still copying the assignment, which is clear. And I don't know what to do. Probably after the pandemic, we should have some rehabilitation hospitals for, for those people who are addicted to copying assignment. I run out of, of tools and tricks to stop this. Okay, so uh, for the assignment, as I said, there are very common few little mistakes I would like to point out. And here is the assignment. So I'm going to go one by one and show you what is the common mistake and why Tahir insists to do that is because what you see right now, probably you'll see it one more time on your midterm exam. So let's make it clear and make sure that you guys are avoiding all those little mistakes. So when it comes to selecting minimum slab thickness based on our concrete manual, you guys know it's not very difficult. There's a table in the code that tells you here is your minimum one-way slab thickness. Okay, if I remember correctly, you have to divide your ln divided by 24. And why 24 is because it is one end continuous. Clear? One end continuous. Okay, so when you divide the clear span, and looks like we have a little bit of difficulty here because we have two clear spans. Here is your first one. It's from this point to this point here. And I think this one, I think it's 4,000 millimeter. And the other clear span is from here to there, and this one, I guess it is 3,400. And so if you want to find the minimum thickness of the slab, you want to go ahead and divide your 4,000 by 24. Why 24? Because it's one end continuous, one end continuous. So next is, I think the number that I got was 162 millimeters. And I said here round up to nearest 10 millimeters. So with this rule here, it looks like we're going to 170. Some of you went to 180, which I have no idea why. If you went to 180, it means you added an extra 10 millimeter, which simply doesn't follow either the metric rule, which is next 10 millimeter, or the imperial, which is the next half inch. So if you even want to stick to the imperial, you want to go with the 175 mils, okay, which is a 7-inch slab. So anyway, so that's how you find the minimum thickness of the slab. For number B, which is finding the factor, the load on the slab, very simple. You just have to multiply the thickness of your slab, multiply by 24, and this will give you the self weight of the slab. You add to that your SDL, superimposed dead load, and this will give you your total dead load. Then you combine them in a load combination 1 and 2, and so this will give you your factored load on the slab. Okay, for C, which is classify slab panels into one way or two ways and show load path, let's take a look at the configuration here. Some of ask me, do we need to add a column here or column here? Guys, I'm not asking you to change the statical system or the structural system of the slab. So this beam here, it's still stable. It still sits on those edge beam along grid line A and grid line B. So no need to add a column at this point here or at this point. That's not needed. Now, what you have to do is you look at, obviously we have two slab panels because my beam arrangement simply divides the entire slab into two slab panels. And since we have for both of them, we have beams all around, then we look at the shape of the slab by estimating what we call slab rectangularity, which is very simple. It is the longer dimension of the slab panel divided by the shorter dimension of the slab panel. For the first panel, it is 8600 divided by 3700, and that exceeds 2. And for the second one, it is 8600 by 4300, and that's exactly 2. And you guys know from 2 and above, it is a one-way slab in the shorter direction. And so we have load path going into this direction here, which is this direction. So we have a load path going into this direction, and another a load path going into this direction. Okay, and so now next part is ask me where is your or how many design strip. Looks like we only have one design strip, and please watch my screen. Here is your design strip, because as I said before, when you secure all the load path, you're done. You don't need any more design strips, and you can see one design strip can do it. The next question is, this design strip, is it simply supported? Is it cantilever? Is it continuous? Let's look at how many support point. Let's count, please. Here is one, so that's one support point. Here is two, that's a two support, like number two, and this is the third support point. So basically, we have two spans and we have three support, and this is called continuous two spans. Okay. Then you put the loads on top of the continuous two spans, and what you do next is you verify the condition or the conditions on manual to use the design aid. Should I build a SAFI model, or I can use a simplified method to find the moment and the shear for this statically indeterminate structure? To do, you have to check for conditions. Number one, prismatic, which is always the case. We do not change the thickness of the slab from one panel to the next panel. We typically keep it the same. This means it's prismatic. Number two, do we have uniform load? Yes, we do. Number three, do we have equal span or with extra maximum of 20%? Very simple. You divide the 4000 by 3400. If this division is less than 1.2, great. It means we have, yes, they are not equal, but this addition or extra did not exceed 20%. The last condition is your factored live load. Remember, factored live load divided by factored dead load, not the opposite. Factored live by factored dead should not exceed the two. If this is happening, then we can use a simplified method. Now, there is something, probably it's a fault up end, and I want everybody to pay attention. Please pay attention. I'm going to say something that I never said it in the class. So please take a note with that. I'll give you some time. I'm going to say something right now which I have never said in the class. So please take a note. So you guys, when you look at the approximate bending moment, the code says at this point here, it is WL squared divided by 16. Can somebody check that with me? This is square, so W, the factored load WF multiplied by the span, clear span squared, divided by 16. Is that correct? I think it's correct, Please
Yeah.
take a note the following. which is actually, the thing is, the manual is kind of lazy. They create one chart and they say use it for beams and use it for slabs, one-way slab, but then they come back and put a footnote, and they said if it's a slab resting on a beam, this moment is not 16 anymore. So please take the note. So the note is this number for slab. When the slab sits on beam, this number is W factor multiplied by ln square and then divided by, the difference is the 24. The secret is 24, not 16. Okay? And remember, you apply this only for the slab resting on a beam. However, still the chart is the same if the beam is resting on a column. Guys, remember, the same chart, we can use it to find bending moment for continuous beam and one-way slab. If you're using it for finding the moment on a continuous beam, great, no change. The only change is when you use the same chart to find the moment on one-way slab sitting on beams. The moment is not over 16, it is over 24. Hopefully this is clear. And again, I didn't penalize you for anything on the assignment because I have never said it. It was a footnote that we never covered under the chart. Hopefully everyone is clear. Okay, let's move on
Where,
to the next.
sorry, Tahir, where is that footnote exactly?
So if you have the, because you guys never bought, you never bought the manual,
Mm-hmm.
you never bought the manual, and this chart, it doesn't belong to the to the digital file available on State Library, because when you buy the hard copy is two parts. One part is the manual, and the second part is a numerical example on the code. So since you're using only the PDF file available on the library, so you will not know what I'm talking about because you don't have the book itself. But here is the thing. If you own the book, you will see I have that, you have the chart that is I provided on my PDF file, and below the chart there are some footnotes. Okay? Again, don't worry, don't bother. All you have to do is take a note when you use this chart as applied to slab sitting on a beam, the end moment is over 24, not over 16. Is that clear, guys? Hamid has a question.
So just to double check, that's for a slab, that's for a shear on a slab sitting right on a beam, right?
It doesn't affect the shear. This affects only the bending moment. So you can see the shear stays the same. It affects only the end moment. Even all the moments are the same. The end moment, you can see it means on this point is over 24, and on this point as well, it is going to be WF multiplied by L sub N square divided by 24, not by 16. So very simple change. When you estimate your M1, 2, 3, 4, 5, then M1 and M5, which they are in the moment, you divide by 24, not by 16. Is that clear?
Okay. Yeah. One more question then. Is that that's still assuming monolithic, right?
Exactly.
Monolithic. Yeah. Okay.
Otherwise, it will be zero, because if it's not monolithic, then the moment is zero.
There's
There is no restraint of the rotation, and the moment is equal to zero. Hamid, put your hands down if you're okay, please. Thank you. Okay, so now one of the very, very common mistakes on this application for you guys, some of you are using the 4300 and 3700. Are those clearest bands? Those are center line. Guys, I'm referring to the 4300 and the 3700. Those are not clearest band. The clearest band are the one that I mark with red. Please use these numbers when you estimate moment and shear force. Do not use, actually, it's not a mistake, actually. It's kind of easement. It is, I would say it's a smaller number. And by using the smaller number, it means you're getting less moment and you're getting less area of steer. Okay. Uh, okay, so I guess everything guys have done right. The only thing I can give you is the details. When I ask here, I'm very specific. I say here, draw a slab plan view with the required reinforcement. Okay, so here is what happened. Some of you did a cross section, so show me a cross section same as the one I showed in the class. That is not required. And some of you showed all the rebars in, look at this, huh? They showed all the rebar. I'm not asking you to show a bar by bar all the rebar, otherwise it is too heavy, right? And that is what I showed you in my Revit model. In my Revit model, I generated all the rebar. However, for a structural drawing, we do not show all the rebar. We show one bar, an example of where is the rebar and is it top and bottom, and then together with dimension line that shows the extent of the application of the rebar. Guys, please, if you don't know what I'm talking about, review lecture notes. Lecture note has an example of how do we show the slab reinforcement on a plan view. Okay, and I'm telling you, some of you they don't know what I'm talking about, and they get some help from other students. I have seen 3 assignments copied. They show all the rebar, all of them. And some others, they are really, guys, when you follow me, your life is way, way simpler. When you follow me, your life is way simpler. And I'm very, very sure of what I'm saying. If you follow the devil, your life is hard. If you follow me, your life is so simple. You just have to follow, read the numerical example on the lecture notes, and your life will be super easy. Don't go any other way. Guys, with this is what I wanted to say about assignment number 5, and hopefully those common mistakes, we can avoid them in the coming midterm exam. Now, I still have a few things on my agenda I want to talk about before I hit the discussion for today. Number 1, I sent you a midterm exam instructions. This was sent over your email, and it was also sent on MS Teams. Please spend some time. I know it's kind of lengthy, and I know that you already read this before, but there are a couple of things new, and I can maybe save your time and say it clearly. Number 1, you are not getting 2 hours, 15 minutes this exam, because simply after you have Dave, and this is a kind of a disrespect from my side if I go over his time. So that's why we agree I will go only for 1 hour 50 minutes with only 10 minutes for scanning and submission. So that's one thing. Hopefully everyone is clear. It was sent. Please don't ask me in the exam that am I getting extra time? No, you're not getting extra time. The only ones get extra time, the students with accommodation, and that's it. And accommodation, you guys know, it means you have applied through SAID system, and they allow you to get extra time in your exam. And that's not by instructor, that is through SAID. Done. Okay, so don't ask, please. And I don't want an accommodation to ask me, am I getting extra time? No, you're only getting 2 hours multiplied by 1.5. That is 3 hours. Thank you so much for cooperation. Number 2, for the midterm exam review, I have time. I will assign time on Wednesday morning, which we have a class. So this is not an extra time. This is your class time. So you guys know that Wednesday we have a class from 8 to 10, correct? So whatever time you choose, whether the first hour or the second hour, it will be assigned for your questions for midterm exam number 2, which will cover one-way slab flexure design and beam design, flexure design. Okay, so that's for the midterm exam review. So please, between now and Wednesday morning, please have all your questions ready to be answered on the class. Also, not to overload your brain with more information. On Wednesday, there is no new material will be taught. Okay, so what are we going to do in the next 1 hour of Wednesday session? You guys will work on assignment number 6 in class. So if we're able to finish all the questions regarding midterm exam in half an hour, then the rest of the class, you guys will work with my help on assignment number 6. I find it very helpful for you. It reduces your stress. You have me in class answering question if you have any, and it saves your time outside the class. Okay? So Wednesday, there is no new material in the class. It will be questions about midterm exam plus your assignment number 6, which I give you. Again, you can work for 1 hour and 30 minutes, whatever you can finish. And then if there is a little bit left, you can finish it outside the class. And the due time, I think it's still, we have plenty of time. I gave you 1 week from Tuesday, actually from today, which we will finish today. So which means the assignment submission will be due to this coming Tuesday by midnight. Okay, so hopefully this enough time for you to do it. And that's for the review. Any question regarding what I said so far? Do you guys have any question or concern regarding what I said so far? Also, last thing, I submitted your midterm exam results. That was sometime on, I think, Saturday or Sunday. I know that some of you may be disappointed. Not very, like not many. Some of you uh, don't get like the right answer and not really, you know, maybe it was not your day that day. So please don't give up on my course. At the bottom line is, are you guys enjoying the course? Are you learning something new in concrete design? Please never give up on the course because I got not the mark that I expected on midterm exam. There is still midterm exam number 2. There is still, we have a couple of assignment left. So I think the last assignment will be assignment number 6, sorry, 7 for the column. And typically I cancel the one for the footing. It will be just material from my side with no assignment. So basically, you will submit assignment number 6 about beam shear design and number 7, which is column design. No more than that, because remember, we're approaching where like the last part of our course, huh? So again, my advice for you is, even if you don't get or you didn't get the mark that you anticipated for your midterm exam, please do not give up on the course. You still have midterm 2, final exam, and then also we still have a couple of assignments. So still lots of mark in the class. Okay, looks like that you guys have no comments and no complaint about the marking. Last thing is, pretty sure that you received some email probably this morning about something called SFQ, which is a student feedback questionnaire. And it opens today. It opens for 7 days. The deadline will be November 24th by midnight, so 1 week from now. And I always remind my students that this is your time to say something about the service that you received. Okay, so you have been receiving a service for the last 10 weeks. Okay, you have some feedback probably about, this part of the course is very theoretical, this is very dry, there is no practical application of this course. All of that, if whatever you feel from your perspective, and your perspective is very well respected. Like some of you already have some experience, you bring the experience to the class, and whenever you put some input on how to improve the class, this will be very appreciated. Please do not use SQF as punishment tools. I'm not talking about myself. I'm talking about your your 6 courses. SQF is not punishment tool. Is not a revenge tool. It is a way for you to say something, and something, it has to be objective. Objective, it means something not very vague, something not very subjective, very objective. Be to the point. Say, this the way we handle or the way we deliver the material or the quality of the material. Be very specific to the point. Okay. Your response, and you do not imagine how much your response is very important. I myself, I'm gonna tell you my how I handle the SQF. I have been in SAT for for 7 years now, and probably got few of them, more than 10. And I look at them whenever somebody will say his language is he has a very strong accent. He says words different the way I typically hear it. I just ignore it, and not I ignore it because I don't appreciate what you're saying. But the thing is, I have no way to fix it. I'm 47 years old and I cannot, I'm sorry, I cannot. Even if I go to night school, it will not do anything to my language. My language, my language, even my kids, they they make fun of me for some words that I say. Okay? And actually, you know what? I'm not really offended because I find it very funny. Even people they speak native English, like I want you guys to hear for somebody from Scotland. Okay? Those are native English speakers, and I bet you if you follow them. Oh my God, I used to have some of them, and my ear are used to like is used to like the not British English. British English is so heavy for me. I'm used to the North American English. But anyway, everybody, and you know what? This is the diversity. That's us. Like that we are a diverse community, and we have to enjoy it. Enjoying to Egyptian who speaks English, Filipino who speaks English, uh, you know, Indian who speaks English. I would say I enjoy it. I enjoy it myself. I'm not gonna make fun of it. Okay. So anyway, so there are a few things that I cannot change, and that's why I cannot help you, even if I love you and I go to a night school to learn more English. There's nothing I can do. But tell me something I can do. Okay. And I think that's about it. Please don't ignore the SQF. I know that you're busy and totally understood, and probably you will have to fill a few of them. But I can tell you, if you fill the SQF, you care. If you don't fill the SQF, simply you don't care. So show your care to our program, to the people that, and change your life. Guys, listen to your, like, look at yourself 2 years ago. You came to us. I'm talking about the majority of you. You came to us with zero knowledge about construction, about CVT. Look at yourself after 2 years and how much knowledge you learn with us in CVT. So many diverse topics about hydraulics, and about surveying, and about contracts and regulations, and about steel, concrete. This will change your life. This will change your life. I have seen some people coming to our school. They are from high school. They know about a little bit about math, about physics, but we simply change them to become a CVT. If you appreciate that, it is time for you to pay back a little bit. Okay, I'm gonna stop at this point. I'm not gonna preach you, but you guys are adults and you know what I'm talking about. Okay, now I guess it's time we spend 30 minutes about instructions, and here is what we should cover in our class today.
Tahir?
Uh, Nick?
Yeah, I think your comments are disabled because there are some comments in the chat.
Uh, didn't see anything coming through, never. Okay, so so Domenico, like, oh my God. Uh, okay, here is a funny story, guys. Here is a funny story since we're talking about steel. Okay, please. I need to tell you a story. So it was Friday night after I teach like my surveying class of last week. And to be honest, I was like, oh my God, I was yielding. You know the yield in steel, yield. I was yielding, and I know that I have this much assignment to mark and this much midterm exam to mark. So I called one friend. I called him and say, "What do you have tonight?" And he said, "No, I'm free." I said, "Okay, we must meet." Okay, I wanted to go out. Otherwise I'll go nuts. I will go crazy. So I went and I wanted to meet with him. So we agree on the time, agree on the location. Okay, and I'm driving on to or going to where we meet. And then on the way, one student, without saying names, simply texted me and asked me that you guys have an assignment with some other instructors and you have an assignment due on Friday night. Probably you know who this assignment is, right? And the student having problem with the assignment, and the assignment is a civil 3D assignment. It's a civil 3D assignment. Don't say your name. Don't say that. Is that Domenico?
Yeah.
Okay, go ahead.
No, I was saying it sounds like a Dave assignment.
It is Dave assignment. And you know, I'm not blame. I mean, nobody can blame Dave. It's Friday night. It's you know a Friday by 4 o'clock. People they turn off the PC. They just go enjoy their life, and you should do the same thing, right? And so Dave never responded to this student, and the students you know felt you know helpless. Like you know I have an assignment to submit. David is not responding. You know I'm gonna go nuts and as much I was happy, I was super happy. Like you know, they feel that you know I am the rescue. Like you know, they texted me and asked me how can I do this part, and because I said I have lots of experience with Civil 3D, so they asked me. And look at this, I'm driving. It is Friday by 7 p.m. I'm driving, and and I cannot call. And you can imagine how difficult to explain for someone what to do using text, like you know, hit here, click here, and without visuals, right? It's very difficult. I'm super stressed. And the good news is finally this person responded to me, and after a few back and forth text, the students confirmed that you know they are able to do it, and they are able to submit the assignment. So that was really like funny, like Friday by 7 o'clock. I'm with my friend trying to enjoy some time, and then. But anyway, I'm happy that this student is able to feel some help and get some support and is able to submit the assignment. Okay.
Does it mean it's hard to be a teacher, sir?
You know what? I've never felt it so hard like this semester. I've been teaching, and I'm not sure if I told you that already. I've been teaching from 1996, and with few interruption that I went to my PhD, which I was still teaching at U of C as TA, and then went few years for industry, like you know LRT and structural engineer. But I would say most of my life I spent it in academia, and but this year I felt like I'm really, and I know that it's not all. I don't want to complain because if I complain, then you say, okay, here is the big boss. The big boss is complaining. So what can we do? Should we cry? I don't want to be weak. I'm just like doing my best, and I'm you know I even comment on my Facebook that I survived another week. I hope that I can survive the next 4 weeks and get to the Christmas. It's just overwhelming, you know, situation. You know, Domenico, you know, I know a little bit about steel, and I'm less qualified than whoever is teaching you steel. For sure, he is way more qualified than me. So probably you can ask him. Muhammad, thank you so much. And again, it's just my responsibility. It's kind of a long queue. You can see I not only looking of what I'm doing now, but I also have to like plan for what's happening tomorrow, what's happening this week. And otherwise, it will be a big failure for me if I don't look forward and plan for you know for today and tomorrow and the next week and so on. Okay, so and I want you guys to please, one of the key success for any of you is time management and planning. If you just go without plan, that is the start of the failure. Make a plan, and this plan applies on everything, on your week, looking like 1 week ahead, 1 month ahead, 1 year ahead, 10 years ahead. Like short-term plans and long-term plans. Okay, when you are super busy, look at the short-term plans. When you are not that busy, look at the long-term plans. Okay? Any other comments or something you want to share? I'm pretty sure that I can get through my material in 1 hour. So we still have more time if you want to share any ideas about our classes. No? Okay. So let's go ahead and let's look at the material for today. So guys, as I said last class, we were covering beam shear design, and I know what I'm going to say right now was kind of a little bit of overlap. I don't want to start from the middle, so I'm going to start again from example number 2, where we're trying to design a beam for shear. So we have a beam, and obviously the beam we're trying to take care of is a simply support. Why? Because you can see we have 2 columns and we have 1 span. So this is what we call simply supported beams. The center line to center line dimension is 6 meters. The column dimension is 400 mil. And from both information, we can simply find clear span. The beam cross section is shown on the right. It's 700 deep by 600 wide. Some information about material. We're using 25 MBA concrete, and F field as usual is 400. The beam has tension bars of 30 m, and we are going to use 10 m stirrups, and the concrete cover is 40 millimeters. Now, very important, we said beams and slabs, they are not subjected to axial force. If you draw the axial force diagram, it will be 0, no axial force, no tension, no compression. And that's why, since we have no tension, no compression, then we can use a simplified method from the code. Let's move on. So first thing you want to do is you need to find the effective shear depth, which is called D sub V, which is related to the D, which is the effective depth. We've done this already, so it's very simple. How we estimate the D, we go with the 700, that's H, minus the cover, minus the stirrup diameter, and minus 1 bar over 2, half bar. And this will give you a 635. The next is you simply have to decide or find the 2 values, a 90% of D or 72% of H. You find the 2 numbers, you pick the maximum, and this will give you your D sub V. So here is your D sub V, which is effective shear depth. Remember here, by the way, so the rounding here is not for anything. It's only for ease of calculation, and I will show you how. Using the 571.5, it will simply lengthen the calculation without any good reason. So here I went with 570. Okay. Clear span is very simple. Look at this. Where is clear span? I'm going to mark it for you. Clear span is from this point to this point here, which is simply 5,600 millimeter, the clear span. Remember, I said here, we better use clear span to find the shear because simply they give us less shear. If you use center line span, it looks like you will get more shear forces to design for. Next part is the problem is very simple. The problem, it says here your GL is 100 and your live load is 60, and you can see I'm merging them in load combination number 2 to find finally my factored load. And you guys know, for a simply supported beam, in order to find the maximum shear at the face of the support, what you do is you take the load, you multiply it by the clear span, you divide by 2. Why 2? Because we have 2 supports. So half of the load will go to the left support and half of the load will go to the right support. So here is your shear force at the face of the column, So where this is where you get the shear. So the shear here is 602 kilonewton. Now, finally, what we have to do is we need to play a little bit. We need to find my shear envelope. Okay, so how do we find the shear envelope? Not very difficult. So you can see here, Here is the shear at the face of the column. Here is the shear at the face of the column. And remember, at the center of the beam, remember this line here, it is not the other support. This one here is the center or the midspan. And you can see I clearly said it here. This is half of the beam because the beam is symmetric. And once the beam is symmetric, it means we have to design half of it. And whatever we get, we can mirror around the midspan or the center line, and we can simply design the whole beam. So every time I show you one diagram, I'm not really drawing the whole beam. It is only half of the beam. And this applies for simply supported beams. Now, once you have this, you guys know that we discussed already that at the center or midspan of your beam, the shear force is not zero. Does anybody know or remember why the shear force at the midspan of a simply supported beam is not zero? Does anybody remember or study the class? So why do we have a shear at the mid of the span of simply supported beam is because of the live load. Live load is transient. It can simply occupy the entire span, or it can occupy partial of the span. And we looked at this last class, and we said that when we occupy the half of the span of live load, this will give us some shear in the middle, and this value is very simple. This value is 1.5 multiplied by the live load. It's over there, huh? This is 1.5 because we're factoring, and this is my live load, and multiply by the clear span over 8. So 2 and 4, you can combine them as 8. So you'll get 63, which means the shear force at the mid span, 63. You simply connected the 63 with a straight line to the 602, which is the maximum shear at the support. And then we also discussed in the last class about we can do some reduction. You can tell if I don't do the reduction, this will be my design shear force. Okay, but we said we can simply cut. We can cut our shear envelope at distance dV. So all I did here is I went and I took my 570, which is my dV. I put it here from the face of my column, and then I simply trimmed my diagram. What does it mean trimmed? It means this distance here, or this diagram from here to there, and from here to there, this doesn't exist anymore. Huh? This part here has been removed, which means when we cut our diagram at distance dV from the face of the column, look at this. Instead of me designing for 602, I'm designing right now for 492. 492. And if you wonder why or how Tahir found the 492, this is pure math. Pure math. And where is the pure math? It's over there. So this is how Tahir found or cut the diagram at distance dV from the face of the column. Not very difficult. So what you have to do is you have to take this rectangle from the business. So you remember the rectangle here is 63. So you simply have to subtract the 602 minus your 63. And simply this will give you this dimension from here to this point here, which is how much? It is 539. And if this dimension is 539, so you can do similarity of triangle. Remember, this is 570, and guess what? Not very difficult. From this point to this point here is how much? Is not very difficult. It is 2800 minus 570, and this will give you any help? Can I get some help, please? $2,800 minus 570. I need some help. 2,000. No, please write it because I cannot see the chat.
2,230.
2030.
Okay, so guys, this is whatever left from, and you can see we can do similarity of triangles, and the math is here. So 539 over 2,800 is equal to x, and what is x? X is simply, it's here. Probably I can mark it for you. So we're trying to find this dimension here, okay, which I call it X. So this X here, you do similarity of triangles as per this math here. Define X, and remember, to find the shear force, you simply have to add your X plus your 63 over there, okay? Remember, from here to there, this is 63. So finally, your shear force after distance dV, which is 570, is very simple. It's X plus 63, okay? So not very difficult. And remember, I'm going to clean it out right now. And what you see is my shear envelope with a value of 63 in the middle and a maximum value of 492 at distance dV from the face of the column. Okay. Now, once we know the envelope, so what you see here, that's called the envelope. I'm going to write it for you. So that's called shear force, not diagram. This is envelope. And simply, what does mean envelope? It means there is no a single situation that the shear force can be more than what you see. Not a single situation. Whatever the live load goes in the middle, goes to the left, goes to the right, jump, run in the air, doesn't matter. Your shear force cannot be more than what you see on the screen, and that's what you should look for, an envelope, not a diagram. Because diagram, it corresponds to one load configuration, and if the load configuration changes, then maybe we can exceed the value on a diagram. But the envelope, which is simply the maximum, it means there's no way for the force to exceed the values in the diagram you can see. Okay, if everybody follows, then we can proceed to the next step. Next step is you have to find what is the maximum VR maximum. Very important, please don't ignore this. Before you even spend a minute to design your stirrup, don't do that. Please do the following, which is very simple. You just have to use this equation to find what is your VR maximum. And as simple as, once you find your VR maximum, you compare this VR maximum against your VF. And you can see, where is my VF maximum? It is not 602 anymore because this part is not true. And your VR maximum is here, estimated at distance dV from the face of the column. So as soon as your VF is less than VR maximum, it means the concrete dimensions and the F prime C for your beam, it means, and whatever stirrups we place, your beam to fail in a brittle way. This whole thing is to avoid brittle failure in shear. You can write it in plain English. This condition here is to avoid beam shear brittle failure. And remember, if this condition is not met, it means if your VF exceeds the VR maximum from this equation, as simple as no, don't continue. You have to change concrete dimensions or concrete compressive strength. And then we can re-estimate the whole thing again. But don't continue. However, in our case, you can see it's very simple. Fortunately, the VF is less than VR maximum. It means we can proceed. And I think we're very close to where we stopped last class. So what we do, guys, is, and I asked you last class, should I take the VR maximum here, the VF maximum, which is estimated at distance dV from the face of the column, should I design my stirrup to accommodate and be able to support this big value here? Yes, you can do that if you're rich. If you're rich, yes, you can find what should be the spacing between your stirrup that can make your beam strong enough to take this much. However, and you can take the whatever spacing, you can apply it everywhere in your beam, from column to column. However, if you want to save some stirrup, some rebar, this is the most economical way to do it. How? Not very difficult, and you will see, you will enjoy it. It will make sense for you. Wherever on the beam we can simply eliminate all the stirrups, we will do. Wherever we can use minimum stirrup, we will do. And then finally, if we need more than the minimum, then we'll do. And that's why we split our beam into different regions. I'm not going to say 1 or 2 or 3. I'm going to say for now, let's start with region number 0. And as I said, guys, Tahir doesn't care whether you call it region 0 or zone 0 or zone 1 or zone X. Doesn't matter for me. Really what matters for me is, which will help you, is this statement. Very simple statement. What is region number 0? What's happening in region number 0? I said here, no stirrups. It means concrete only. And why can I get rid of all the stirrups? Because the code allows me. The code says if your beam, if your VF exceeds your VC, then of course concrete cannot do by itself. Then we need to add stirrups. And also, if your beam depth exceeds 750 mil, then we need stirrups. And you can see my case is not. My case is my beam is 700, which is less than 750 by the code. It means any area on or any section on this beam that I can my VF less than VC, it means you know what, concrete can do by itself, no need for stirrup. Does it make sense for you? I need to get some noise.
Yes.
Okay, so what happens here? What happens here, guys, is I will try here in this very simple calc to see how much concrete can take by itself. By itself, no help from stirrups. So what happens here is we just repeat the equation, which is phi c lambda beta square root of f prime c b sub w sub dv, no invention. And remember, beta here, beta here. How do we find the beta? The beta comes from 11.3.6 on the code, and it depends. It depends on is my member is a special type, like a very slim beam with a thickness less than 250 mil. It is not, which means no, I'm not gonna use 11.3.6.2. I will have to shift myself to 11.3.6.3. And then if you remember, there was A and B. It depends on, do I provide minimum stirrup or I don't have minimum stirrup. So you can see both of them right now. I used here 0.18, which we use 0.18 or 80%, 18% if I have minimum shear reinforcement. Or I also found my beta if we have no transverse reinforcement. So I have here 0.15. Okay. And you can see I already estimated two numbers, like 200 kilonewton or 166. So those are the shear capacity for concrete only without any stirrup. It depends if I add stirrups. So this one will be the shear capacity, the 200. If I have no stirrups, so concrete can take only 166. Okay. Let me ask you. I need some help. So I'm asking you, in zone number 0 or region 0, which number should I use? Should I use 200 or 166? Please don't chat with me because I don't see the chat.
200.
200.
200. Okay, so can you please read? The 200, it came from using the beta of 0.18. And when do we use 0.18? When we use minimum shear reinforcement. In zone or region number 0, are we using any stirrups?
No.
So what does it mean? It means I'm go VC in zone or region number 0. It is 166.
But
You have
what?
to use 166.
But wouldn't no stirrups be the minimum amount because there's none there? So that
the code doesn't mandate the use of stirrups if your VF is less than VC and your beam is less than 750. And this is happening in zone number 1. Zone number 1, the VF, we will mark the end of zone number 1 where still concrete can do by itself, no need for a stirrup. And remember, look at this box in red here. Beam depth is 700, which is here. Look at where we started. The beam depth is, it's over there. It is 700, which means
I get that. I just when when it says the minimum amount, I guess that's assuming that there has not, because the minimum amount is 0, I would think. Because if you're not using any, that's
No. The code has a saying of what is the minimum and where should you provide the minimum. The minimum is not 0. In the
Okay.
code there is a specification for the minimum and where should you must provide the minimum.
okay. So that's assuming that you do have to use them then. Okay.
Okay, so we can see here the start is here. Since the beam is 700 mil, which means less than 750, it means I can live without the stirrup wherever VF is less than VC. Remember, it's conditional, huh? It is conditional. I can live without stirrups wherever VF less than VC or equal. Does it make sense for you?
Yeah, now I get it. I understand now.
You can tell from my diagram, you can see here concrete can take 166 and you can see here the shear force at the middle, it is only 63. And you can see if I go away from the middle of my beam, shear force is increasing. And then you can tell here at some point your VF will become equal to your VC. Once you pass this point, a millimeter past this point, it means no, my VF 166. It means concrete cannot do it by itself. It means from this point on, I will need some stirrups. Are you guys following?
Yeah, that makes more sense now.
Okay, so guys, here is the point, which is kind of one penny math. Look at this. I need to find where should I end my region number 0, where I have no need for stirrup. Very simple. Very simple. Look at this. Wherever or whenever VF exceeds your VC, then I will start need some help from stirrup, which simply all you have to do is you go along this diagram here, along this line, and locate one point where your VF, where your VF is equal to 166, which is where to get this number? It is here. This number is there, this number. Okay? And again, this is not super math. I'm going to box it out for you. Here is how you find your x0, which is the end of region number 0. Not very difficult. It's similarity of triangles, huh? Similarity of triangles. The only tricky part is it is not triangle pure. We have to take this rectangle, huh? Probably I'll have to mark it for you. So once you take this rectangle here from the business, then it became a similarity of triangles. I'm gonna fill it with you guys. So take this guy out of the business and it became similar triangles. So how? Very simple. You just have to subtract your 539 from the 63, and then you do similar triangles. And remember also you do the same thing here. 166 minus 63. Look at this, please. I'll dimension for you. So this distance is 63. It's a rectangle. So, and remember that this dimension is from here to there is how much? Is 166. So simply you have to get the difference, which will be 103. With the 103 triangles to find. So what happens? I've done this and I found my x is equal, or x0, because I will do this several times. X0, it marks where is the end of region 0. So I got here 535. And guys, you can imagine, 535 is not really a nice number. Because in general, this number can be anything, can be 535.7. Would you design a beam and tell whoever is building this beam, stop or start your stirrup after 535.62? That's not really acceptable. You just have to use a kind of nice number. I used here, I rounded, I said, okay, you know what? Half meter without any stirrup. Okay. Are you guys following? Because if you follow this one, your life is super easy for the next discussion. Are you following?
Yeah, we're
Yes,
following.
sir.
Okay, so let's move on to our region number 1. Remember, I'm done with region 0, region 1. I don't care region 1 name. I care concrete plus minimum stirrups. That's really what I care, because simply that's what tells you what to do next. So in zone or region number 1, in this zone, which will start after zone number 0, we will start to add minimum stirrup to help concrete. And why, Tahir, is start with minimum stirrup? Because simply you cannot add less than the minimum stirrup. Gorda, you cannot add less than the minimum stirrup. So the minimum stirrup is defined by some equation, okay? So please look at, again, those equations from the code. So in the code, it says A, V, or S, the spacing. Probably you can call this one S1 because there are two spacing. So you can estimate the spacing corresponds to the minimum stirrup from this equation here. AV multiplied by F field divided by 0.06 square root of F prime C BW. And if you put all the numbers, you will get 444. Remember, what is AV? AV is, we have 2 legs and we have 10M stirrup, and that's why your AV is 200 mil. That's why we got here 444 mils. As our first condition, by the way, we're not done. The code has also a different limit for the spacing. So the code in another clause, it says the spacing, it should be the minimum of 2 numbers, 600 millimeter or 0.7 of your DV. So what happens here? I have done the math and I got here 339. So let me ask you guys, if the code in one location said that's your maximum, you should not exceed this number, and also you should not exceed this number, and also you should not exceed this number, let me ask you, which number should I use?
The 444 because that's the maximum.
Okay, so I'm gonna go with Gord. So the Gord is saying use 444. If I use 444, am I meeting this requirement?
No.
No. Okay, so looks like you will estimate 3 numbers and pick the minimum because the minimum meets all the condition. While if you pick the maximum, you're meeting this condition, but violating this condition, which in the code, you must not violate any of them. So please use the minimum among those 3 numbers. So the first number is AV F yield divided by 0.06 prime square root of F prime C BW. So that's 1. Number 2, 600. Number 3, 70% of DV. Whatever is the minimum, this will be your spacing or the maximum spacing between the stirrup. Because simply if I use the 399, it meets the 600, it meets the 444. However, if I use 600, I violate both of them. If I use 444, I violate the 399, but not the 600. Is that clear?
I see. I was looking at it backwards. I was thinking of the 399, well, rounded to 400 as like
no.
longer.
That's a later decision. So when I picked the 399, I said, listen, Tahir, you know what? I know some of you will say, Tahir, if we round to 400, it means we're violating the 399. I can tell you, remember, I already rounded, if you remember, I already rounded here. If you go back to the 570, my DV was not really 570. If you remember, my DV was 571.5, and we're very fraction of a millimeter even. And that's why I'm not going to go to 375. I will just, say this is roughly 400. But in general, I give you the rule here. The rule here is you should round down to the nearest inch, 25 mil. Okay, now I know that my minimum stirrup is this. Let me write it for you. So the minimum stirrup is 10M at 400 millimeter on center. Okay, that's the minimum. You cannot add less than this. And what happened is I'm going to find, okay, this minimum, how much force it can contribute. How much force it can contribute, which I need to find what is my VS. Not very difficult, so you go ahead and it's phi S AV F field dV cotangent theta divide by S. So if you do the math, minimum stirrup can give you 138. If you add 10M to legs at 400 on center, it gives you 138. Now, in zone number 2, if I add this stirrup, now what is the total beam capacity in this zone? Look at this, not very difficult. Your VR in region number 1 is going to be VC plus VS, which is the minimum stirrup. And remember, there is a tricky part, and please take a note. That's a very common mistake. What I'm going to say right now is a very common mistake. So you can see if I go back here, there was 2 numbers, 200 and 166. In region number 0, I used 166. In region number 1, how much should I use for my VC? Any help?
200.
Guys, 200. Why 200? Because again, I go back here. Whenever you provide minimum stirrup, I can use beta is equal to 0.18, and this will change your VC a little bit. Okay? So you can see here I'm using 200 plus 138. I got 338. It means when I provide my minimum stirrup, so the total resistance of my beam in region number 1 is 338. 338. Now, obviously, it doesn't help the beam until the end, because look at this. What is my VF that I need to design for, which is here, from here to there? How much? Anybody remembers what this number is? 500. Can anybody go back in the slide and tell me how much is the VF?
539.
Huh?
539.
I don't think so. It's 490 something. The
Yeah,
D
492.
492. Actually, it's on my slide, but I didn't see it. It's over there. Huh?
Oh,
It is V. It is. Remember, it's not here. Huh? It is at the face of your column. Face of your column. Not at the face. At distance dV from the face of your column. Okay, because we already cut this part of the diagram. This part here is not really counted. So anyway, you can see if my concrete plus minimum stirrup, it can give me 338, and you can see at the dV from the face of the column, I need the resistance of 492. So which means zone number 1 or region number 1 cannot go all the way to the end. No, cannot, because minimum stirrup is not sufficient. So what I need to do here is, let's find where should I end zone number 1. Pure math. I'm not going to do it again. You guys enjoy your time and then find. So what happens here from my math? I figure out x1 by the similarity of the triangles is 1428. And again, I pick the nice number. Okay, 1400. So 1400 is x1. Remember, x1 is measured from the mid span to where region number 1 ends. And remember, the first 500 was zone number 0 or region number 0, so which means 900 millimeter will be zone or region number 1, where we add minimum stirrups. You can see it's on my screen. In this region here, I'm adding minimum stirrup. Again, one more time, do I need to continue calculation? Yes, you have to. Why? Because you can see VC plus VS with minimum stirrup, it can give you only 338, while your VF at distance dV from 100. So which means zone number 2, it doesn't go to, zone number 1 doesn't go all the way to the face of your column. That's why I go here to last region 2, and in region number 2, do you see the difference? Do you see the difference between region 1 and 2?
Yes.
Yeah, the difference is in the first region, you didn't use the 63 kilonewtons on the bottom, and in the second region, you are.
No. In region number 1, I'm using minimum stirrups. In region number 2, I will use more than the minimum stirrups. I'm talking about. Okay. Again, when you find your x1 or x0, it's a math, huh? I need to take this rectangle at the bottom, which is 63, to find your x1 and x0. Doesn't matter. You whether for region 0 or region number 1 to find x0 or x1. Okay, really the difference between region 1 and 2 is we will need more than the minimum, because you can see the 338 is less than 492. So if I add the minimum stirrup, it doesn't make my beam safe to the end. It makes my beam safe until X1. Is that clear? Is that clear?
Yes, sir.
Okay, so let's move on, and this will finish our example now. So I moved to region number 2, where I'm using concrete and stirrup. Please, in the exam, in the assignment, please be clear. You must write for me this statement here. Okay? Now, what we have to do is we say, okay, you know what? Here is my VF, which is 492, which is a distance dV from my column. And then I'm going to take minus 200. Why 200? Because this what concrete can take with minimum stirrups or more. So I found this number here, which is 292. What is this number? This is the responsibility of the stirrup. So if my VF at distance dV from the face of the column is 492 and concrete can handle 200, it means I need to come up with a stirrup spacing that can provide this 292, as simple as that. Now what we have to do is we use the same equation that I used before, but in kind of rearranging the order. So before I use it to find a spacing, now I use it to find here, I use it to find the VS. Here, I know the VS, how much VS is, but I want to find the spacing to do that. So you can see here, I just use this 292 goes here, but for the units, I use the 1000 because everything here is Newton, and this number is in kilonewton, and that's why I multiply by 1000. So at the end, I got here 189.8. It means if I use 10M stirrup, 2 legs at 189.8, this provides a resistance of 292. And if you add 292 to my 200 for the concrete, it means now my beam is safe. Obviously, you cannot build a beam with a spacing 189.2. If you do that, trust me, people, they will curse you on site. They will curse you. Nobody does that, huh? So we always round to the nearest inch. Nearest inch. Now, round up or down, what do you think? Round up or down? Any hand?
Round down.
Round down, because if you round up, it means you're making a more spacing between your stirrup. It means you have less stirrup in your DV, and then your VS will be less than what you need, which is 292. You should round down. And that's what I did. I went from 189.8 to 175. And then I went back here and I said, okay, now, if I place a distance 175, how much my stirrup can do? Very simple, same math. The only difference is this time I'm looking for VS. So I'm kind of reordering the equation. So I used here 175. I got here my new VS. If you add the VS plus your VC, so zone number 2, here is your VR. Are we safe? So this much can be covered by concrete, and this much can covered by 10M stirrup, 2 legs at 175 millimeter on center. And then finally, this is your total shear resistance in your zone number 2, or region number 2. Are we safe?
Yes.
Yes, of course, because look at this. We need to resist 492, and my beam capacity is 516.7, which means yes. All I have to do is the rest of the beam. So we have 500, that's region number 0. And then the following 900 will have minimum stirrup, which is 10M at 400 on center. And the last region here will be 10M at 170 mil on center. And this will make my beam safe all the way to the end. Okay, and again, very simple. I'm trying to show you kind of design summary. So the design summary is first 500. So which means from here to there. Remember, this is the center line of your beam. I analyzed half of the beam, and all you have to do is mirror. So the first 500, no need for stirrups. And then the following 900, from zone number 0 to this point here, this is 900 mil. This zone I provide minimum stirrup, which is 10M at 400 mil on center. and then from this point on all the way to the face of the support, I provide a stirrup which is more than the minimum, which is 10M at 175 on center. Okay, and then finally, guys, I want to tell you something before the break, that when you do that, that is not sufficient. You need to provide more information for the builder. You need to tell them what is your shear, cross section. Why the cross section is important for your design, for your construction.
To see how the stirrups is arranged.
What is the geometry of the stirrup? Because it can be 2 legs, it can be 4 legs, it can be any amount of legs, because sometimes my forces are so high, and it will be to the point that the spacing will be so tight. If the spacing is so tight, what you should do? For example, if based on my analysis, I figured out the spacing and it came out to be 10M at, let's say, 25 millimeter on center. What do you think? Anybody built a beam for bridges? This is the case, by the way. For bridges, the case. The shear forces are so high, and you'd go through the design. Your final finding is, no, I need 10M stirrup, 2 legs at 25 meter on center, which is super tight. You have a problem here because concrete cannot go in between.
So it brings it into 2 layers if you cannot adjust your width.
No, actually, it's not 2 layers. You go here and add more legs. If you add more legs, what happened here is your AV will change. If you add more legs, guys, this number will not be the same. This 200, it is 2 legs 10M. If you add more legs, or maybe change the diameter of the stirrup, then this will simply enlarge the spacing. Hopefully this is clear. When we add more legs, we are increasing the spacing. When we increase the diameter of the stirrup, we also increase the spacing because we're simply adding more AV.
No, I'm saying is why are you allowed to change the width of your region?
Change the width of what?
Of your region, like or the width of your beam. Of you're only allowed to do that
Not
maximum
the beam. I'm not
width.
changing any width of the beam. I'm changing here, for example, at this. So the beam is still the same, but I'm adding here another stirrup that goes this way. This doesn't change the width of the beam. I'm adding more legs.
Oh, okay. Okay.
Hey guys, any questions so far? If you have no questions, I will just break. I'll have to drink some water, and I will see you guys in 10 minutes. Thank you.